Laundry Day right now doesn't exist on ISS. And so laundry day today would be to bundle up your clothes and send it into basically a chute or a capsule for later disposal as it re-enters Earth and gets burned up.
This is CES Tech Talk. I'm James Kotecki. CES 2023 is January 5th through 8th in Las Vegas. We are here to get you hyped and get you smart about the world's most influential tech event. Today, we can send people into space, but will they have clean socks when they get there? Let's explore cutting-edge laundry technology at the edge of space with Mark Civic, PhD and Distinguished Research Fellow at Procter & Gamble. Mark, laundry in space. What are we talking about here?
Well, actually, today, James, there is no laundry in space. And NASA would like to learn about the viability of doing laundry in space. Today, actually, the astronauts wear their clothes for 3 to 4 days, and then they discard them and they're actually burned. But for long-term and deep space missions, this is not viable. So NASA approached us to determine the viability of doing laundry in space. One of our programs, part of this mission, PG Tide, that we've been working with them over the last 18 months or so, was to do just that and show them that, in fact, you can do laundry in space.
I want to get more into the technical details of what exactly that means. But just to tie this in specifically to CES 2023 and let everyone know, you will be a part of a panel called Tech Dev in Low Earth Orbit, an Astronaut's Perspective. And I believe that's scheduled for Friday, January 6th at 9 a.m. Who else is going to be on that panel? What's the overall? Is it not just about the laundry piece? Is it about other technology as well?
Yes, it's actually with the ISS crew in flight during this mission. And then it'll also have representatives from the ISS National Lab. And the objective here is to display some of the opportunities of using the zero gravity platform that's on ISS to develop new technologies that will obviously benefit humanity.
Wow. So, and you're saying that the ISS will actually be calling down, the crew will be calling down to the panel and be on a video display to participate in the panel during CES.
That's my understanding, yes.
That's going to be fun. Okay, so let's start with you and how you kind of approach this topic. What's your background? What's your role at P&G?
P&G, my role is to develop new technologies that drive superior performance across a number of different touch points for the consumer, with a heavy emphasis on sustainability. And this project with NASA ties that in quite nicely. P&G in the past and over the last several years, have been focusing on driving more efficient wash systems to lower our CO2 footprint and the CO2 footprint utilized by the consumer. And in an area of closed loop systems that NASA has to operate on, especially in flight or in off-planet habitat, there's no better way to learn in this context to force you to think differently and to utilize our resources more effectively.
And so let's, for the audience, help them visualize what it might actually mean to do laundry in space. I believe this is with the P&G product Tide. So there's some laundry detergent involved. Are we talking about the liquid? Are we talking about the powder? And then what is the astronaut doing? Is there a machine up there doing it? What is actually going on?
So this is kind of broken down. We broke this down into a couple different bite-sized pieces for us and for NASA. First and foremost, this project actually got started as part of the Artemis logistics reduction team. So imagine sending a crew to the moon and they were going to spend a month's worth of time. It costs quite a bit of money to ship a kilogram of materials. So our objective was, okay, could we do laundry in 1/4 or 1/6 of the gravity of the moon or of Mars? And what would it take? And then secondly to that, all the attributes that are contained within a closed environment would have to be taken into consideration. For example, there's no use of solvents, there's no use of silicones, everything has to be degradable. The water that we use will come out as a coffee beverage, so it has to be fully recycled and recovered. So we developed a detergent system to understand what was required by NASA from the constraints point of view. And the also important part of this is that it had to drive hygienic cleaning. As you may know, the astronauts have to exercise about 2 hours or more a day to maintain bodily health and muscle strength. So as a result, we designed a detergent that would really drive against that need with taking account all the other constraints together. Part of our efforts with NASA was to show that, in fact, we could do that. The other part of this stuff was, could we do that with a restricted amount of water? And no different than we have the water constraints on Earth, we also have water constraints in flight, whether it's on the National Space Station or on a planetary habitat in the future. We're going to have a limited water to deal with, and so we have to recover that water and recover it effectively every time. So with those constraints in hand, we took a crew of 4, what would be a week's worth of, quote, laundry in space, and how much laundry we could do. Was it effective in achieving that with the least amount of water? And we could cut the amount of water used by the astronauts by 42% of what is used here on Earth for the detergent system that we developed with NASA. The other part of our work with NASA and the National Lab, along with our implementation partner, Omnitech, was to learn about stain and stain removal. With the microgravity environment, with in-flight constraints, do we really need as much detergent to remove the soils they partake in? The second thing is they do eat different foods at a different frequency. So we actually did a lot of our stain removal tests with the foods and drinks that the NASA folks and crew use in flight as part of our staining and stain removal studies.
You're convincing me that this is moving from something that the average person might think is trivial to like, no, it's actually essential. We have to figure out how to do this if we're going to have a long-term future in space. Getting back to the reality of what's physically happening, is there a laundry, this is maybe a silly question, is there a laundry machine in the ISS? Like what is actually doing the washing and how does it work?
So for ISS in particular, there is no washing machine. That would be the next phase of our work. So what we've done is we've done a lot of our learning here on Earth. And then what we used the National Lab for was 2 main experimental paths. One was to understand stability of our detergent and detergent systems. We're obviously leveraging catalytic chemistry, enzymatic cleaning, and other functional actives. We want to make sure those were stable to microgravity, to radiation, and space flight travel. And the second part of that was, okay, how do we do stain removal? And then we take those learnings combined, and how do we think about a different way of doing laundry in space? Because as you can imagine, you can't have a front-load aging machine having some centrifugal force because that could throw the flight vehicle off balance. So doing laundry in a very different way with different resources and also drive efficacy. So the astronaut or crew gets what they desire, no different than what the consumer desires here on Earth. They don't get to go to the store and get new detergent if their detergent runs out or goes bad. So we had to make sure that everything was good so that Tide works every time for them.
For some reason, I'm just not able to picture, it's laundry day on the ISS, the astronaut is there, they have their dirty shirt. Like, what are they, if there's no laundry machine, and there's no sink, presumably, are they taking the Tide product and just rubbing it into the shirt? What are they actually doing in that moment on laundry day?
Laundry day right now doesn't exist on ISS. And so laundry day today would be to bundle up your clothes and send it into basically a chute or a capsule for later disposal as it re-enters Earth and gets burned up. How we foresee laundry day for the crew in the future and working with NASA for a habitat, of which the process that I just described around cleaning clothes with our detergent and the constraints of NASA is actually to be studied on a effort called the CHAPIA test, which is going to be a grand analog test that's supposed to commence sometime next June. Again, what we're doing there is for a typical laundry day by a crew member would be 2 crew would actually do their laundry for an hour or 2. And then part of this would be what was required is during the drying step using a heat pipe type technology, capture the humidity condensate because we got to recover all the water that we put into the clothing and wash system and retrieve it back so that your net water loss is minimized. Then that wash water is actually sent to either a bioreactor or a degradation system to make sure everything's degraded, filtered out, and then that water goes back into storage after purification so that can be reused the next day. And that sequence would go every other week for each of the 2 crew members of using crew of 4 as a model to build from.
And is it in a bag or something? Because they can't obviously have a basin sitting around.
That's right. It would be in a contained device. And as far as the instrument development, that is something that NASA will need to work on for future work. So we've developed what is a viable system for consideration for in-flight travel and certainly planetary habitats, which is a really important milestone for us. We also demonstrated, as we've just received our hardware back from this latest mission on SpaceX 24 and 25, that our detergent have a comparable stability to that of a companion set of materials that we stored here on Earth. We actually flew nine different formulations and 13 different enzyme ingredients and some other biological actives that help us clean. And those are all showing really nice results for us, which is encouraging. And again, you just can't keep sending things up to space. It's just cost prohibitive.
And so to summarize this, kind of where P&G and Tide is at right now with this research, it sounds like you've done a number of different tests in zero gravity environment. Presumably that looks something like an astronaut is given a set of instructions about different chemical things to mix or do, or put this stain on something and try to get it out. There's basically different tests that the astronauts are running in a pre-planned, pre-scheduled way, much like they might run any other experiments that government agencies or other companies might send up with them. And that's kind of the stage that we are right now. If everything goes perfectly, how soon will an astronaut be able to actually have clean clothes on space?
So to your first part of your description, yeah, we worked extensively with NASA, the crew, and Marshall, our implementation partner, Omnitech, who has worked the interface between private industry and the government to implement studies. And we went through a series of protocols because we looked at this as a scientific experiment that has consumer impact. And in this particular case, the astronauts are a consumer. So looking at how easy it is to remove stains, that was a great part of the study. And then as we received our hardback, we're looking at those results compared to on our system. As far as the implementation of this moving forward, well, as part of the Artemis mission, which is being planned to send astronauts by around 2025, it's not that far after that if a planetary habitat is established on the moon to study, then moving from the moon to Mars, a machine to require this will have to be developed within that time frame. So we're talking maybe 2 to 3 years. So it would have to be in consideration for such a feat.
What have you learned by working with NASA? You're a private company. You're getting astronauts to conduct research for you in zero gravity and space-based conditions. It sounds pretty cool, but what do other companies listening to this podcast, other people who attend CES and might want to work with NASA in the future, what are some things that they should know based on your experience?
Yeah, no, it was a learning experience. First and foremost, and this is also part of the recognition to the ISS National Lab. The National Lab actually governs some of the astronaut and crew time as well as launch dates. So we wrote a proposal actually to the National Lab to secure astronaut time and look at a timing sequence that we could meet their launch schedule with what we were trying to do along with NASA. So it's critical to work with the National Lab to secure the time and the resources necessary to do that. Also in concert with that is what will the research do to improve the life on Earth, as well as what will it do to improve the life of space travel? A topic of this nature, which is really a lifestyle topic, no different than understanding skin conditioning, shampoo, the way we treat ourselves for long-term health and healthiness and viability, no different with this particular situation with cleaning clothes. So we put together a proposal with the National Lab to understand the detergent side of the equation as far as stability of our ingredients and will it be affected by any kind of deep space mission. The second part of it is learn some of the physics and science of stain removal. No different for another private firm would have similar questions on, what does this pharmaceutical do? What does this metallurgy do? How does zero gravity affect the performance or integration or synthesis or biological construct that may be different than what's applied here on Earth? And that was one of the key questions we had with flying in zero gravity is if we're going to send something in space for a 3-year mission or for a 1 or 2 year mission, will our enzymes be active and do what they need to do when they're exposed to those conditions? So this stability test was pretty critical to our understanding of that.
How controlled are these experiments? By the time that an astronaut has an experiment in their hands and a list of instructions for what to do, is it hyper-controlled down to the minute in terms of what they're actually able to do? Is there any room for improvisation or mistakes or sudden discoveries that, actually, I might want to follow up on this thing because I accidentally mixed this thing and it turned out a different way, but could be interesting? And are you, as P&G, able to kind of be in touch with the astronauts in some way during that experiment to kind of guide it and shape it and improvise with them?
Yeah, no, it's a great question, James. And yes, we were part of the experimental work. We did spend a significant amount of time with NASA and NASA safety, as well as with our regulatory and safety groups. Safety is the utmost importance. As you can imagine, you're in a confined space for a long period of time. So the crew safety is number one. With that said, we're also doing a lot of experimentation, not only to help the crew, but also to help humanity here on Earth. And NASA sees this, the National Lab sees this, and we see this. So what you have to do is when you're thinking about what you want to learn in zero gravity in a confined or closed loop system, what are the must-haves, what are the need-to-haves, and what are the things you can put to the wayside that may not be that important? And what we ended up doing, actually, we were looking at stains, and one of the stains that the crew entertains quite a bit is sriracha, because they start to lose the sense of taste and they would like to have the hot and spicy. Well, if you can imagine you're trying to remove a sriracha stain from a fabric, that becomes a chili pepper or hot pepper that becomes aerosolized. And so we had to keep that to a minimum, while it's still a reality that they entertain to. So we worked with a group on how do we keep this to the right exposure limits that could be contained. If something went awry, how we would manage that. And we took all those safety considerations into play. Now, as far as doing the day of the experiments with the crew, which was really exhilarating and fascinating, and the crew became the consumer too, not just an experimentalist, but the consumer. And so working with Omnitech, who has a direct feed with NASA operations, and our NASA ops person. There's a number of experiments, as you can imagine, going on in the National Lab by several crew at the same time. So there's a chain of direction by each of the NASA ops folks with our implementation partner. And then we would dialogue with them during the experiments themselves. And of course, the crew are scientists in their own right, and they have the sense of curiosity or an observation. We had a number of visual cameras going on at the same time, and we had a protocol to follow that we worked through step by step what was going on. But we also had some pause elements that NASA put in with us to check and see where we might anticipate some questions on function of our chemistry, what's happening if this happens, what do we do? There were some questions by the crew member that was doing the work at the time about how much chemistry to apply for the size of the stains that we were seeing. We were asking them what they observed. There was some interesting learnings on pigment and, do you actually grab it? Because if you're the consumer, you probably grab it and remove it and then use a little bit of more solution, then the stain's completely gone. And we blended the ability to do scientific studies with what the consumer would do and then really what the crew would do. Because at the end of the day, we want to minimize the amount of clothing the crew uses and still give them the delight that if they have a stain and then they're going to speak with the public audience, that they could get rid of that stain pretty quickly without using a lot of crew time and still get the quality and the expectation that a person would like to have without having a stain on a fabric. But during the experiments themselves, we were able to interface with the crew during all the studies that we had, which was really a plus.
I'm just in awe of how complicated it actually is to do laundry in space. I would have never have imagined all the different factors that you have to think about when you're talking about they eat sriracha because they lose their taste. And that creates a chili pepper that if you aerosolize it in a closed environment could become problematic. You went into this obviously with a bunch of experience and knowledge. Do you ever get surprised at just how complicated it is to where you think you've cracked it and, oh no, there's some other factor in a space-based environment that you haven't considered that kind of throws all of your calculations into disarray?
Yeah, thinking again, coming back to the safety question, the crew, the oxygen source, the lifestyle is the beginning of their most important attributes that they have within a contained environment. So, we actually had to look at a situation where we don't affect any kind of flammability, anything of that nature. We don't put the crew at risk at any time. We have to think about the size of the fabrics we're using so that we don't increase the flammability risk. And you're saying, well, why is that the case? Well, the oxygen content within flight has actually increased, which helps the crew mitigate any kind of bends or anything that would happen during spacewalks and the like. So the action level is actually a little bit higher than what's here on Earth to mitigate that. This thing is zero gravity, so we had to mount our fabrics in a certain way so they don't float. You have to think that the consumer can lay something down and it stays there, but when you're doing this in flight, you have to, we use Velcro, we use a certain type of mounting devices such that we could learn as if the astronaut was doing this in real time for a stain. How would you actually execute this in a way that would work? And then on the backside of that, you have a certain amount of moisture that you have to deal with. And then the humidity is pretty comparable to what we have here on Earth for an average say, Midwestern city. But you have to still then let these things air dry, then obviously assess them afterwards. So we had to take into account a number of different things. We supplied them with stains that we made here on Earth, and then we had them stain also in microgravity to understand those dynamics as well, because the hardware prep was a considerably longer period of time. So we wanted to look at both dried-in stains and then acute stains to see the efficacy of some of the technologies we're working on.
So we've been talking about the many differences of being in a space-based environment and how it makes doing laundry challenging and different. But how is the technology and the research that you're developing here for this project going to come back down to Earth and ultimately affects the way that consumers do their clothes as just part of their everyday chores here at home on Earth?
P&G was actually working in this area for a bit of time, James, on how we drive cold water cleaning, how we drive cleaning with less amount of water to drive efficiency, and then how to work with different treatment conditions and mechanical processes within the machine itself to minimize the water utilization during the whole process. We were able to, and I think I may have mentioned earlier, we were able to reduce the amount of water utilized in this process by about 42%. Obviously, there are some conditions that are quite different than what the consumer expects on Earth. But the detergent design for this can be a very, very viable option for us to consider for future use here on Earth. Some of the processes we're looking at, it's okay, how do we bring this to life for the consumer? And then how we bring this back to some of our missions for our own company around water utilization and minimization of CO2 production by both the consumer and making of our products. If we can get the consumer to reduce their laundry temperature during washing 3 or 4 loads in cold water in a given year, that would reduce the amount of CO2 by 27 million metric tons. And that's what the consumer could do today. And part of the technologies that we deployed within this development with NASA, we're deploying in many of our products today to allow the consumer to achieve that objective and save money just in heating water. And then obviously, as we do more with our machine manufacturers, how do we leverage the water that we use today in a more effective way?
And I think this ties in nicely to the theme of CES 2023 of human security for all, which is this wide-ranging, kind of all-encompassing concept about how technology addresses global challenges, food access, climate change, sustainability in all its forms, economic, healthcare, all these different things. But certainly that sustainability piece and that energy use piece and that water use piece that you seem to be talking about here kind of plays into that. Any other thoughts about how Tide and P&G kind of thinks about this idea of human security?
Yeah, so we look at human security in a lot of different ways. Certainly, reduction of CO2 and greenhouse gases is pretty critical to our 2030 objectives and really reduce greenhouse emissions. And we're looking at not just for what the consumer does, but how we make our products. The other thing, too, is for the consumers is how can we clean and give them the superior cleaning they look for day in and day out. And as we've gone through a number of different scenarios, such as COVID, and the like, hygienic clean is also key to the safety factor that we're providing to the consumer. We're always trying to drive the best cleaning possible and that the consumer will experience every time they use the Tide and any of our P&G products, such that they have the superior cleaning that they expect every time without question.
Mark Civic of Procter & Gamble, thank you so much for joining us on the show. This has been fascinating.
Thank you for the opportunity, James. I'm looking forward to CES.
Well, that's our show for now, but there's always more tech to talk about. Here's a preview of the next CES Tech Talk.
1 trillion gallons of water a year come through leaks just in homes across the United States.
Please subscribe to this podcast so you don't miss a moment and get more CES at ces.tech. That's ces.tech. Our show is produced by Nicole Vidovich with Mason Manuel and Kristen Miller, recorded by Andrew Lynn, and edited by Third Spoon. I'm James Kotecki, talking tech on CES Tech Talk.